Hello students, welcome back again. So this is our video number part 2 where we are going to discuss about the chemical properties of hydrogen sulfide, right? In our previous video we have learned about physical properties and today we are going to see the chemical properties. Okay, so let's come to the board. First property, that is acidic property. So, if we could see the aqueous solution of H2S, okay, if we could test the aqueous solution of H2S with the help of a litmus paper, then we could see that it will turn the blue litmus paper into red. So, what does it mean? It means that the aqueous solution of H2S shows acidic property or shows acidic character. So, here we could see whenever H2S is in its aqueous solution, it will dissociate to form H plus ions. Okay, by this nature, H2S will decompose to form two ions. First, it is H plus, another one SH minus. This is the first one. Secondly, this one it will again decompose it will again decompose to make again H plus along with sulfide S2 minus ion. So in total H2S decomposes to make 2 H plus ion and 1 sulfide ion. Okay, 2 H plus ion and 1 sulfide ion. That means what? That H2S, as it is making 2 H plus ions, so it is a dibasic acid. It is a dibasic acid. Though H2S is a mild acid, but it is dibasic in nature because it contains 2 protons or 2 H plus ions. So now, due to the acidic property, whenever H2S is allowed to react with a base like NaOH, KOH, so it can make 2 types of salt. Okay, due to the formation of 2 types of anion. One is bisulfite and this one is sulfite. Okay, so whenever we are reacting NaOH plus H2S, so then what will happen? The cation will be added to the anionic part. Cation will be added to the anionic part, forming a salt, that is sodium bisulfite. Sodium bisulfite. Okay, and OH plus H plus. OH minus will be added to the H plus ion, making H2O. As we all know that whenever a base it reacts with an acid, it makes a salt and water, and this reaction is called neutralization reaction. So in this process we will get a metasulfide or bisulfite salt and water. But whenever NaOH reacts in this type reaction, or in this case it will make Na plus OH minus. So Na plus it will react with the S2 minus ion, making sodium sulfide Na2S, and this OH minus it will react with, so here the balancing should be 2 NaOH. So 2 OH minus will combine with 2H plus, making 2H2O. Okay, so 2 NaOH plus H2S, they will react to form the salt, that is sodium sulfide Na2S plus 2 molecules of water. So due to the acidic property, whenever they react with base, they make a salt and water. Clear up to this one? Okay. So next is that number 2, that is reaction with oxygen. Reaction with oxygen. Okay. So now H2S could react with oxygen in excess amount or in lower amount. That means if we take oxygen in greater amount, then it will give a product, and if we take oxygen in lower amount, then it will give another product. So let's check. First, H2S plus O2. Suppose here oxygen is taken in excess amount, and another H2S plus oxygen where oxygen is taken in lower amount. Okay. So when we have taken oxygen in excess amount, so here sulfur will react with oxygen making sulfur dioxide, SO2. Okay, sulfur dioxide along with the formation of water, H2. And here when oxygen is taken in lower amount, here the sulfur will be released only and oxygen will be combined with H2O making water. So it is clear, it is evident from here that what happens when oxygen is in excess amount, then we will get SO2, and when oxygen is in lower amount, then we are getting sulfur here. After that you have to balance this reaction. Okay, 2H2S, 2SO2, 3 oxygen. Okay, so you have to balance this equation. So next, number 3. Number 3 is precipitation reaction involving hydrogen sulfide. Precipitation reaction involving hydrogen sulfide. So hydrogen sulfide has a unique property to precipitate the salts of copper, zinc, lead type of metals. Okay, so whenever we pass the H2S gas through the alkaline solution of the salts of copper sulfate or it may be copper sulfate, okay, or it may be lead nitrate, not alkaline, acidic solution of copper or lead. Okay, so then after reaction it will make the precipitate of these salts. So just see example number 3, precipitation reaction. So suppose we have taken copper sulfate. Okay, copper sulfate that is also called blue vitriol. Okay, so the aqueous solution of copper sulfate, the pentahydrate of copper sulfate is called blue vitriol. So whenever copper sulfate it reacts with H2S, then from this reaction copper will combine with the sulfur or sulfide making copper sulfide or cuprous sulfide, cupric sulfide, CuS, along with H2SO4, and this one is black in color. So after the reaction we could see that whenever you have taken an acidic solution of copper, okay, any salt of copper, and you have passed H2S through it, after reaction you could see a black precipitate at the bottom of the container or at the bottom of the tube. So the black precipitate is due to the formation of copper sulfide. Same type of example, suppose you have taken a salt of zinc, that is zinc sulfate, plus again H2S gas is passed to the acidic solution of zinc sulfate, which will make again a precipitate. Downward direction means that it will be precipitated at the bottom of the container. So here we will get white precipitate of zinc sulfide along with the formation of H2SO4. Okay, so by this reaction we could precipitate the metallic sulfides. Okay, the metallic sulfides are precipitated which we could differentiate or which we could identify by their color. If it is black in color, then it could be copper sulphide or lead sulphide. If it is white in color, then it could be zinc sulphide. So this method is used for identifying the metals or the cations, that which metallic cations we are using here. Okay. Next one, that is reducing property. Next is the reducing property of H2S. So H2S is an ideal reducing agent which is used to reduce different reagents. Like, first of all, suppose here I have taken the acidic solution of potassium dichromate. Potassium dichromate has the formula K2Cr2O7. Okay, it is orange in color, plus acidic solution means H2SO4 is present. Okay, so after this reaction, H2S, it will reduce potassium dichromate into chromium sulphate, Cr2SO4 whole 3, which is green in color. Okay, which is green in color, plus H2S will be oxidized to sulfur. Okay, H2S will be oxidized to sulfur and this will be reduced to chromium sulphate. Along with, we will get K2SO4 plus water. After that, you have to balance this reaction. So by this method, we could see that H2S reduces this reagent into chromium sulphate. The same type of example we can also see for KMnO4. If you use here KMnO4, potassium permanganate, which is pink colored. Okay, so KMnO4 will be reduced to manganese sulphate, that is MnSO4, and H2S will be again oxidized to sulfur. So various reducing properties we could see here, okay, which proves that H2S is a very good reducing agent. Just giving two examples of reducing. Suppose you have taken a halogen and H2S. So H2S reduces the chlorine to HCl. So how you could identify that chlorine is reduced here? Because as you know, reduction means addition of hydrogen. So as hydrogen is added here with the chlorine, making HCl, that means it is the reduced product. Okay, plus sulfur. So any type of halogen, whenever they react with H2S, they are reduced to their halogen acids. Okay. Next example, that is reaction of nitric acid with H2S, concentrated nitric acid. Okay, so whenever we are taking concentrated nitric acid here, so as we know, any type of acid, mineral acid, whenever it is concentrated, it is a very good oxidizing agent and H2S is a very good reducing agent. So what will happen? H2S will reduce it, okay, making NO2, nitrogen dioxide. So it will be reduced to nitrogen dioxide and H2S will be oxidized. H2S will be oxidized to sulfur along with the formation of water, H2O. Okay. So many reducing properties are there which you could find in your notes that I have given. Okay. So these are the reducing properties. So next is that reaction of H2S with sodium nitroprusside. So what is the formula of sodium nitroprusside? Na2 Fe Cn whole 5 NO. Okay, this is the formula of sodium nitroprusside. So in its alkaline solution, whenever we are adding H2S, whenever we are passing H2S gas through the alkaline solution of sodium nitroprusside, then it will become the solution which was colorless initially. It will be converted into a purple color solution, forming this compound NOS. Okay, so this compound will be formed which is having a purple color or a violet color. So by this method H2S can be identified. Okay, so if into the freshly prepared solution, freshly prepared alkaline solution of sodium nitroprusside, if H2S is passed through it, then the color will be changed into purple colored liquid. So by which we could identify H2S gas. Another method is also there by which we can identify H2S, that is, if you take a lead acetate paper, the formula is Pb CH3 COO whole 2, lead acetate. Okay, the lead acetate paper you have to take and you have to keep it in the flow of H2S gas, or if you have to dip it in the glass jar containing H2S gas, then there will be the formation of lead along with sulphide. It will make lead sulphide, that is black in color, and acetic acid will also be formed from here, CH3COOH. So after this reaction, if you see that the lead acetate paper or the paper soaked in lead acetate, that will become black colored, that means the gas is confirmedly H2S. So by these two reactions, one is sodium nitroprusside test, another one is lead acetate test. By these two tests we could identify the H2S. Okay, and after that you have to read that the uses of H2S, that we how we could use the H2S gas in various purposes. Just like H2S gas is used for the preparation of metal sulfides, like this metal sulfides, like the zinc sulfide, copper sulfide. So these sulfides, these metallic sulfides that are used in the paint industry for the preparation of pigments. Okay, as well as the same reaction, this type of reaction where the precipitation reaction, this reaction we use in the laboratory for identifying different types of cations or different types of basic radicals like copper 2+, zinc 2+, okay, like zinc, copper, lead. This type of cations could be identified from this, and for this way H2S is very important reagent that we could use in various methods, in various purposes. Okay, so this is our today's class. I hope that all of you have understood it properly. I have already given you the notes. Just follow it properly, write in your copy, okay, and check it. So we will meet in our next class. So take care all of you. Stay safe. Thank you.